How you doing, everybody? Let's write this two-column proof for this triangle. Hey, everybody. Let's write this two-column proof for these two triangles right here. Okay, we're gonna start with our given information. GH is parallel to HI. Good evening, everybody. Let's write this two-column proof for these two triangles, triangle HGI and triangle IJK. So let's start with our given information. Line segment GH is parallel to line segment JI. And I is the midpoint of HK. And line segment GH is congruent to JI. Okay, so for the most part, they are already marked on the triangle what is parallel to one another, and they're actually showing us that I is the midpoint of HK. But we just gotta do some filling in the blanks. So let's fill in some blanks. So our first blank we're gonna fill in is the first statement. Our first statement blank should be given. That's pretty simple to see. Okay, our next statement blank should be what? Also, yes, given. Alright, now we gotta actually write an actual statement now. And they said it was given to us. So let's write the actual statement. Statement should be written that what? Our last statement, GH is congruent to JI. Okay. Alright. GH is congruent to JI. As seen there, which is here. GH is congruent to JI. Okay. Now the next statement says that IH is congruent to IK. Okay. The way that we can make those two congruent is by what? Not definition of bisector, but definition of a midpoint, because they told us that I was the midpoint of HK. If I is in the middle of HK, that means I is equal distance from H, as it is also equal distance from K. So, definition of midpoint. Okay, so let's actually mark those down. So let's mark those sides down. So if we mark that side down, this side now is congruent to this side. These two sides are now congruent to each other. Okay, by definition of midpoint. Now, if you notice, it said corresponding. Only time that you have corresponding angles is when you have parallel lines cut by transversal. So let's see if we actually have some corresponding angles. So we have two lines that are parallel to one another and a transversal cutting them in half. So let's take a look at it. So we do have one. We have that angle H, which is here, is corresponding with angle I, but this is a certain side of I. So let's write this up. So angle, in our case, angle GHI is congruent to angle JIK. Okay. The reason why I had to say that because this is a certain side of I. I is sharing two angles. And actually three, but it's showing two angles in two separate triangles. Okay. Now you should be able to see that side, angle, side. And it is stated right here in this sixth reason, but we actually have to give a statement for it. Okay, so let's give a statement for it. Let's get a symbol for it. Triangle. Let's change the symbol. Oh, there we go. Triangle. Triangle. GHI is congruent to triangle JIK. Oh, wrote in the wrong spot. Sorry about that. JIK. Okay, if this is true, now lastly we can say that angle G has to be congruent to J. But what would be the reason for this? Some would say that the reason for this would be angle side angle. Yes, but no. Let's correct that. It wouldn't be angle side angle. It would be because you have two congruent triangles and its corresponding parts must be congruent. It's a short name for it, CPCTC, which means corresponding parts of congruent triangles are congruent, which means that if you can show that two triangles are actually congruent to one another, then its other corresponding parts must be congruent to one another. So G must be congruent to J, and K must be congruent to this side of I. Okay, and along with the last side, which is not even stated, but just to let you know that all the sides must be congruent also. Alright, thank you again. Have a great day.